stages imbalance, the speedup is less. Speedup is due to increased throughput. Its latency, which is time for each instruction, does not increase. Then I will talk about pipeline analogy.
Well, why we need pipeline in the processor?
Because it enhances number of instructions processed at one time. New inputs are accepted before previous accepted inputs become output at the end. When we have several resources, we can pipeline the task. And mixed pipeline includes 5 stages, 1 step per stage. First stage is instruction fetch IF from memory. Second stage is instruction record ID from and register read. Then is the third stage, which is ES, execute operation or calculate the address. Next is the fourth stage. It is MEM, access the memory operands. And the last stage is WB, it write result back to register. Now let me explain what is pipeline speedup. How to say all stages are balanced? Let's all stages take the same time.
I see. Then how to calculate the time between the instruction which involve the pipeline?
How to calculate the time between instructions which involve the pipeline? The formula is time between instructions of non-pipeline process divided by number of stages. Now let me explain what is pipeline using example of Ronnie's system. This row is time. This column is task order, which involves A, B, C, and D. And the first stage is wash the clothes. I represent it by W. Second stage is dry the clothes, represent as D. Third stage is fold the clothes. I represent it as F. And the last step is the fourth step, put the clothes in wardrobe. It's represent as P. Talk about non-pipeline first. Without the pipeline, the Ronnie's process have to go through 4 stages, then only process the first stage of B, which is wash. But if we use the pipeline, it is much more faster. After we wash the clothes, we can proceed to next stage, and at the same time, we can proceed to wash of the task B, which is the first stage of task B. Look at the time required for this process. Without parallelism, this process requires longer time. See from this diagram from 6 p.m. until 2 a.m. However, with pipeline, only 6 p.m. to 9:30 p.m. to complete all the tasks.
Now we discuss about the hazards. And do you have any ideas about hazards? What are the types of hazards? There are 3 types of hazards: structured hazard, data hazard, and control hazard. Structured hazard is required source is busy, then it can affect the program. Then data hazard is need to wait for a long time for previous instruction to complete its data. Control hazard is deciding on the control action depends on previous instruction. Okay, according to the MIPS timeline, they got 5 stages. You know the 5 stages? Now they have instruction fetch, instruction record, execute operation, access memory operand, and write result back to register. I want to use these 5 stages to do the forwarding solution.
Why must use forwarding method?
Like this. According to our knowledge, there are 5 stages of MIPS pipeline. The first one, instruction fetch, and then instruction decode, execute operation, access memory operand, and finally write result back to register. Now I will discuss to you all about the data hazards and the solution to avoid data hazards. Basically, there is time frame 200 picosecond, 400 and so on. And then there are two instructions. Example like this. The first instruction is basically more forward when compared to the second instruction. Then use the 5 stages of MIPS pipeline and insert inside it. When these two instructions is separate, they got many bubbles. This is called data hazards because it will wait a long time to go to the second instruction and the flow cannot go fluently. So to avoid this bubble, we can use forwarding solution. By using this solution, the second instruction can be moved forward and can be connected aligned like this. The side after the execute operation connect to the side before the execute operation. So by using this solution, the flow can be go successfully and then not need to wait for so long.